Here viewers, today I'm going to show the configurable converter in the configuration of the DAP converter. So in this part we will see the discharging mode of this battery. So here at the input side we have connected the battery. So the input voltage now it is input is the secondary bridge. Okay, so here at the input side of the secondary of the DAP converter is connected with this battery, 48-volt battery. Okay, so now the MCB is off, pulse is off. Okay, and we have connected the multimeter. Okay, so sorry, clamp on meter to see the current. Okay, here we will see the current, input voltage. Okay, so now only the change part in the discharging mode of the DAP converter is the current sensor direction. So be careful about the current sensor direction in the discharging mode. If it is not correct properly, then the system will damage. Okay, so all the connections are same, but the only change in the current direction. Okay, so all the connections are same, but the input voltage of the current sensor is now this. Okay, so here you can connect the battery positive voltage. Okay, battery positive we have connected here, and the output of the sensor is connected with the bridge. Okay, so this is the discharging connection of the current. Okay, current sensor of the LV side. Okay, so in the charging what we can happen connection is the bridge output is connected with the positive of the current sensor, and the negative is connected with the battery. But in the discharging, the positive of the battery is connected with the positive of the current sensor, and the negative is connected with the bridge. Same the change we will applied with the primary side also, HV side also. Okay, so the at the discharging you can connect the bridge output with the positive of the current sensor, and the negative of the current sensor you can connect with the load positive. Okay, and the negative of the capacitor or the voltage sensor or the bridge negative DC rail you can connect with the load negative. Okay, so what happen in the charging, you can connect the input DC plus is here, this DC is plus is here, and the output means the minus of the current sensor is connected with the bridge. Okay, but in the discharging what we can do is the output of the bridge is connected with the positive of the current sensor, and the negative of the current sensor you can connect with the load. Okay, so this is the small changes of the connection in the DAP converter of the discharging mode. Okay, and you can do this step first, then you can go to the programming. Okay, so first of all you can connect the controller by using this cable with your laptop, and just open the cube programmer. Okay, just open the cube programmer, open the file. Okay, and you can find this code, a DAP converter 40 kilohertz open loop closed loop discharging. Okay, then you can just open it. Okay, then you can just first connect it, the controller. Okay, then you can just press the download button, complete, and disconnect. Okay, then as previously said, the RS485 is connected with the battery, so you can just connect this cable with the laptop. Okay, so you can just open the software of this BMS. Okay, and you can just go to the COM port section, and you can find the COM port. Okay, 27, then connect it. If the COM port is wrong, then it is not connected, then you can just change the COM port number 23. Okay, COM port 30 you can connect, and then press the connect button. If it is correct COM port, then all the battery data you can get in the software. Okay, now in the software what you can change, you can do the changes is, now it is the discharging mode. Okay, so in the MOS control, you can go to the MOS control section and you can disconnect MOS charging MOS. Okay, and you can apply the set button, so you can just see the MOS status charging is red, and in the error section software lock you can see the red. Okay, so you can do the same thing for the charging. And if you have going to the charging, then you can just turn on the MOS for the charging. Now we have going to the discharging, so we have just only turn on the discharging MOS, we have disconnect the charging MOS. Okay, so now the battery SOC is 62%. Okay, 62% battery SOCs are there. Okay, so now same thing, if you need to log the discharging data, then you can select the discharging. Okay, then after the turning on we will see how to log it. Okay, so now we will see the performance. Okay, so basically first of all you can just disconnect this cable. Okay, then you can press this button, so you can just see battery discharging, and you can just see the open loop mode. Okay, so first of all we will okay, so you can just see by pressing this button we can decrease the phase shift. Okay, and by pressing this button we can increase the phase shift in the negative. Okay, so likewise this you can turn increase or decrease. By pressing this button you can turn on the control. By pressing this button you can toggle the closed loop and open loop. Okay, so first of all we will see in the open loop mode. Okay, so now we have connected the battery with the DAP converter LV side, and the HV side we have connected the resistive bulb bank. Okay, so now turning on the MCB, so we can connect the multimeter also here. Okay, so now you can see the battery voltage is 59.54 voltage and the current is now 0. Okay, because we don't turn on the control. Okay, so also you can connect the multimeter at the output side. Okay, so you can see the output voltage is 0. Okay, now by pressing this button we will transfer power from secondary to primary. Okay, so you can see 49.3 volt is there, and you can see the voltage is gradually increased. Okay, and also you can see in the software the current is in negative. Okay, so -2.8 is the discharging current. Okay, and you can see the voltage is 200 volt. Okay, so 50 volt to 200 volt, and also you can see the current. Okay, almost 0 current is there. Okay, so now this is the H1 pulse and the current, so primary current. Okay, so battery SOC is 62%. Okay, now we will maintain here 50 volt to 400 volt. So now we can increase the negative phase shift and we will see the power transfer is happening or not. Okay, so you can just see the glow of the volt bulb. Okay, so now I am pressing the phase shift. Okay, so now you can see the phase shift is now increase, -3, -4, -5, -6, 7, 8, 9, 10, 11, 12. Okay, also you can see the output voltage. Okay, it is gradually increase, and also you can see the current is also increase. Okay, -1.5 sorry 5.1. Okay, and we will maintain here is the 400 volt. Okay, so 400 volt is maintained here. So okay, so 400 volt is maintained here, 50 volt to 400 volt, and also you can see the current is now -7.3, and you can see the glow of the bulb. Okay, and you can see the current is -7. Okay, and also you can see the shape Okay, so this is the shape with okay, this current. Okay, now we will increase the load. Okay, so here minus 7. So it is, now you can just see it is maintaining 400 volt reference, 400 volt. If you want to maintain the 400 volt here, we can apply the phase shift is minus 24. So in the closed loop it will maintain the minus 23 to 24 volt phase shift with 400 volt output to 50 volt input. Okay, with some ampere. Now I am increasing the load. Okay, so when I am increasing the load, the current will increase. Okay, so you can just see discharging current is almost the 10 ampere. Okay, so you can just see the 10 ampere. Okay, so now the voltage is dip. Okay, voltage is dip, and also you can see the phase shift between the primary and the secondary. You can clearly see by using this slanting. Okay, so this is the H1 pulse and this is the current. So the now in the discharging, the current is negative, and the class slanting you can just see here and here also. Okay, now we will see the performance of this in the closed loop mode. So first of all we can reduce the load. Okay, and you can just see it is maintained here. Now turning off. Okay, so we have turning off the system. Go to the open loop mode, closed loop mode. Here we have maintained the 400 volt output. Okay, with the 10 ampere, maximum 10 ampere we have limit. The battery current is the 10 ampere, we have limited. Okay, so now I am turning on the control and it will try to maintain. So now the battery SOC is 61%. Okay, and you can just see the current is gradually increase. Okay, also it is try to maintain the output voltage is 400 volt. Okay, the input voltage is 50 volt. The current is 7.5. Okay, and here you can just see the voltage is maintained with 400 volt. Okay, so it is also if you can connect here you can connect the battery if you don't need to connect the resistive load. So if you need to connect the battery, then it will work with this CCCV mode. So we have given the CCCV mode code, so you can just see it is maintain the 400 volt here, and the phase shift is minus. Okay, just so you can see the phase shift is exactly same, the minus 25. Okay, and it is maintained the 400 volt. So it is now this system is in the CC mode. Okay, now I am increasing the load. So I am increasing the load, so you can just see the current is increasing. Okay, now current is increased. Okay, and you can just see the phase shift, till the phase shift is -4, but it is in the CCV mode. Okay, so you can just see the voltage is decreased here, and here you can see the -9 ampere current, and also you can see the phase shift. Okay, so H1 and the current wave shape. Okay, just you can I will just increase this big, so you can just see the current. Okay, so current shape you can just see. Okay, now I am connecting the H1 and H2 this is the H1 pulse, and H3 pulse I have connected, and just see the phase difference between here. Okay, so it is going to the negative side. So now I have connected the H1 and H3 pulses. So H1 is the same, and H3 pulse in the discharging it is going to the minus. Okay, minus some phase shift we have seen here, and here also you can just see verified. Okay, and likewise this the current shape is something same. Okay, we have previously seen. Okay, so here the minus 10 ampere current is maintained, 48 volt, some voltage dip are there. Okay, and here it is working perfectly. Okay, so now some discharging are there. So now the battery SOC is 60%. Okay, after some time we will see the discharging of the battery and we will see the SOC. So likewise this, it is perfectly working in the CCCV mode of the tap converter in the discharging mode. Okay, so after some time we will see the battery SOC. So the after 10-minute run we will see the battery is discharging 60% to the 58%. Okay, with minus 9.6 ampere current. Okay, so at the load side it is 1.7 ampere. Okay, so likewise this, the DAP converter is perfectly working with the charging and discharging mode. Okay, thank you.